Hello, welcome back to another video. Today we're going to be looking at cubic functions. So the question reads, the graph of f of x is equal to ax cubed plus bx squared plus cx minus 5 is drawn below. E is minus 1 and 0, g is 5 and 0, and they are the x-intercepts of f. Question 9.1, show that a equals 1, b equals negative 3, and c equals negative 9. Now, since E is, this point E is the turning point and it's an x-intercept, we can use the form for a cubic graph, which is, so 9.1, f of x equals a into x minus x1 all squared, and then multiplied by x minus x2. And we can use this form because E is an x-intercept and it is a turning point. Okay. Next, we can substitute. So f of x is equal to a into x minus 1 is plus 1. So x plus 1 all squared. And then x minus 5. Next, we need a point to substitute because remember we want to solve for a first. And if we look at our equation, they tell us that the y-intercept is negative 5. So this point right here is negative 5. So if I had to write that coordinate, the y-intercept is going to be 0 and negative 5, and we can substitute that in. So negative 5 equals a and 0 plus 1 all squared and 0 minus 5. Next we can simplify. Negative 5 is equal to a and 1 squared and then negative 5. Negative 5 is equal to 1 squared times negative 5 is negative 5a. That means a is equal to 1. Now if we wanted to work out b and c, we substitute that back. So we'll take this and we'll substitute it back into this format right here. So we'll say f of x equals 1 into x plus 1 all squared and then x minus 5. Now we expand. So x minus 1 all squared is x squared plus 2x plus 1. And then that's multiplied by x minus 5. Now you expand. So you're going to get x cubed minus 5x squared. Then plus 2x squared minus 10x. I have to go to the next line, then plus x minus 5. Let's simplify. So the like terms here are minus 5x squared plus 2x squared, and then you got minus 10x plus x. So you're left with x to the power of 3. Minus 5x squared plus 2x squared is minus 3x squared. Minus 10x plus x is minus 9x. And then minus 5. And we've shown now that a is 1, b is negative 3, and c is negative 9. Okay, let's move on. So next question reads, calculate the value of x for which f has a local minimum value. So f, this function, will have a local minimum value at this point here, because this portion has a minimum. This is the minimum portion, or the minimum point for that portion of the function. So in order to get this, we need to take the derivative. Okay, so our function So question 9.2, our function is x to the power of 3 minus 3x squared minus 9x minus 5. We need to take the derivative, and the derivative is going to be 3x squared minus 6x minus 9. Now at this local minimum and at the maximum, you equate the derivative to 0. So 0 equals 3x squared minus 6x minus 9. We can simplify by dividing everything by 3. So 0 equals x squared minus 3x minus 3. Sorry, minus 2x minus 3. We can factorize x minus 3, x plus 1. That means x is equal to 3 or x is equal to minus 1. We know that minus 1 will give us a maximum, therefore 3 will give us a minimum. So therefore x equals 3. Okay, so let's just input that on our graph now. So this point right here, x is equal to 3. Okay. Question 9.3, use the graph to determine the values of x for which f double prime x multiplied by f of x is greater than 0. Okay, let's work out what f double prime x is first. So question 9.3, if the derivative was 3x squared minus 6x minus 9, that means that the second derivative will be 6x minus 6. Now, there's a number of ways that you can do this, but let's solve this graphically. So this is a function, right? It is a straight line. Now, we can plot that straight line on the graph. So if this is the graph, let's plot it. So we know that the y-intercept is going to be negative 6. So negative 6 is somewhere here. Okay? Next, what we can do, let me just neaten this up. Okay. Next, what we can do is we can work out the x-intercept in order to draw the straight line. So to get the x-intercept, make y 0. So 0 is equal to 6x minus 6. That means x is equal to 1. So when x is 1, that means probably around here. When x is 1, that's going to be our straight line. Now we can draw that. So your line is going to go something like this. Okay. A little bit crooked, but I think we get the idea. Let's just extend this a bit. Okay. Now, this has created some regions now. Alright? And let's mark these regions. So we have this region right here. That's where the point of inflection is. Then we have the intercept here. And then we have this intercept here. Okay. So just the intercepts and the point of inflection for now. And we've created some regions now, some zones. Now, they want to know, where will the product of these functions give you a positive answer? Now, in order to get a positive answer, so f double prime x multiplied by f of x must be greater than 0. So either both of them are positive or both of them are negative. So we need to check now, where's both of them going to be positive, where's both of them going to be negative. So using the regions that we've just marked, we can see that both of them will be positive in this area here. So when x is greater than 5, and then both of them will be negative in this area here. Let me mark it. So we can see that both of them are negative here, and here we can see here. Both of them are negative here. So when x is less than 1. So that's our answer. Use the graph to determine the values for x, for which f double prime x multiplied by f of x is going to give you a positive answer. X must be less than 1, or x must be greater than 5. Let's write that out. So x must be greater than 5, and then x must be greater than 1. Sorry, less than 1. Okay, next one, and the last question. For which values of t will the graph p of x equal f of x plus t have two distinct positive roots and one negative root? So this plus t tells us that the graph is being shifted. It's being shifted. So it's either being shifted up, it's being shifted down. And they want two distinct positive roots. So distinct means that they must be different, and one negative root. So what we need to do is we need to figure out the y values. They're not given to us, but we need to work it out. So the first one is f of 3. So what is f of 3? So you substitute 3 into our original equation, and we get negative 32. Then the next one is f of 1, and that's going to give us negative 16. And the last one is it's the y-intercept. Now, what needs to happen is that this function needs to be shifted upward. But it needs to be shifted upward only this much, between 5 and 32 units. Because if it's shifted between 5 and 32 units, then you will get the two distinct roots, positive root and one negative root. Now it's a bit difficult to imagine it, so let me show you what it looks like. So this is our function, okay? And we have the plus t value there. And now what we can do is I can increase the t value. And you can see that as you increase the t value, the graph is shifting up. Now we want to shift it to a point where we get two distinct positive values. So when t is 3, you don't, but when t is 5, you have, 0. So it needs to move between 5 and 32. So if it's 5.5, you have two positive values and one negative value for the roots. And you can see that as we move it up now, as we increase this t value, you still have two distinct positive roots and one negative root up until 32. So the graph needs to shift between 5 units and 32 units upward. That's why I said it is a bit difficult to imagine it, so I thought I would show it to you. So the answer to that last question is that t needs to be shifted between 5 and 32 units. Okay, and that's it. I hope you found this video useful. If you did, leave a like share, subscribe. And if there's something specific you want me to answer or a specific paper to do, let me know in the comments below. And until the next video, bye.